recording, once it's ready, will be posted to the course webpage. What I'll do is I'll just post it to a public-facing YouTube, and then I'll put a link on the webpage. I guess that's not really for your benefit. You're seeing the lecture right now. If there's anything that you want to see again, you'll see it again if you want it. So let's do some things. So let's address this. Let's suppose you know the graph of a function. Maybe it's one of these. And see another function that's exactly that same function, but a constant has been added to the whole function. So if you know the graph of f of x, what should the graph of f of x plus c look like? Anyone have an idea? Let's hear it.
It's up c on the y value.
Yeah, shift up by c, and maybe I'll add that too, in the y direction, which is, I guess, implied by the word up. Like, y is the vertical component. Cool, and we'll check these in a bit by just comparing them with some examples. What about f of x plus c? Yeah.
Isn't that to the left? C.
Yeah, so intuitively you would think, yeah, it's going to shift in the x direction by c, so you would want it to be to the right by c. Somehow whenever you do anything inside of the parentheses, it does the opposite of what you expect. So if you think it's going to go right, it'll go left.
Why does it do the opposite in parentheses?
Nice, we'll talk about that a little bit. And let's talk about it right now. Let's pull up this Desmos demo. So there's a graph of a function, f of x equals x squared plus 2x. It doesn't matter what that function is, it's just some generic function. I've picked a constant, namely 2. There's f of x plus c. So let's just check one thing first. Is purple to the left of red?
What?
Is the purple graph to the left from the red graph?
Yeah.
Cool, so it does. That doesn't tell you why, that just tells you that it does. Let's think about why it does that. So let's see, in order to see oh, I'm not projecting. Let's see, it's going to do something in the horizontal direction. So it's going to preserve the y values. So if I want the graph of f of x plus c, that's recording the y value of the graph when I plug in x plus of it equals y value on graph of y equals f of x at, let's make that x0. So, what does this say? This says if you want to get the y value on this graph, you should look at the y value on that graph, but over to the right. So let's see, just pictorially, if that seems the same based on this. So if I want the graph on this thing at, say, x equals -5. -5 shifted to the right is now -3. So this y value should be the same as this thing at x equals -3-ish. Cool, so that means that the red is the purple but shifted to the right. So if the red's the thing you start with, then the purple is red shifted to the left.
I see.
So there's an argument, but a good heuristic to keep in mind is if it's inside the parentheses, it does the opposite. So with that in mind, let's carry on from there. Negative f of x, what should that do to the graph?
It's the inverse of the original function, so you flip that onto.
Yeah, so you flip it over what? for that negative side. So that's going to like take all of the f of x's, that's all the output values, and make them negative. So it'll change the sign of all of the outputs. Yeah, let's flip over the x-axis, I guess. So that'll flip over the x-axis because it will multiply all y values by -1. What if I put a negative inside of the parentheses? What do people intuitively think will happen there? I think it'll flip over the y-axis. Slash multiply all x values by -1. And let's discuss that for a moment. Like, the heuristic of like, do the opposite of what you expect. Well, I've just written down what you would intuitively expect, right? Multiply all x values by -1. What's the opposite of multiplying all x values by -1?
Dividing by -1.
Dividing by -1. Oh, but that's like the same. So this is one of the interesting cases when a thing is the same as its opposite, whatever that means. What if I take a number c and multiply the graph by that c? Yeah.
Is that stretching it vertically?
Yeah, we'll stretch it vertically. And let's intuitively think y. So what's the y value on this graph? It's the old y value, because the old y value is f of x. And then I multiply that y value by c. So this will, I always struggled with spelling the word stretch, so let's see how I do. How'd I do? Something's wrong. It looks too long. How do you spell stretch?
Oh, there's no A.
There's no A in stretch. No, I'm thinking of reach. I'll get that wrong again at some point today. So stretch vertically by a factor of c, which is why I prefer to write, in fact, let's just multiply all y values by c. Nice. So what do you think should happen if I put the c inside of the parentheses next to the x?
Stretch horizontally.
I hear a stretch horizontally. Ooh, but that's what you intuitively think should happen. So the opposite happens. So what's the opposite of stretching? Yeah, but still horizontally. So this one will compress horizontally by a factor of c, slash you will divide all x values by whatever that number c is. And in order to like just see this happening, let's pull up a Desmos tool. Desmos is perfectly happy to have you declare a function. And let's just see if this checks out correctly. So I think I'm happy to have that there so that I can still have this up. So there's a function. It's the same function as is declared here. This suggests doing a bunch of adding by 2's. So let's just see if each graph behaves the way we think. If you add c outside, does that look like it's shifted up? Nice. And let's see, as c goes negative, does that seem right? Shifting up by a negative should be the same as shifting down? Yeah, okay. Cool, let's put that back at 2. Next one is f of x plus c. We already saw that went to the left. Oh, so if c is negative, if you go to the left by a negative, that means you've gone to the right. Negative f of x, we said that should flip over the x-axis. So all the y values should become negative. Does that check out? Nice. F of negative x should flip it over the y-axis, so it'll do a horizontal flip. All the x values will be negative what they used to be. That look right? Cool. Multiply by a constant, it should be stretched vertically by a factor of 2. So all the y values should be stretched. All right? And f of c times x, that should like compress. Cool. And let's just see what intuition people think. What if that, Well, instead, not 21 over 2. I just want 1/2. For this one, c times f of x. What should the graph visually do if you stretch by a factor of 1/2? It'll shrink. All the y values will get multiplied by 1/2. That look like it did it? All right, next one. What do you think should intuitively happen there? So before it compressed by a factor of 2, so all the x values got divided by 2. So what should happen if I do the opposite?
So kind of like stretch more.
It'll stretch. So if you like, all the x values will get divided by 1/2. But how do you divide by a fraction you multiply by the reciprocal? Yeah, that's multiplying by 2. Cool. Does that feel pretty good?
See, this is the stretch one.
Well, let's see. What I said before is that's like inside the parentheses. So that's a compression by a factor of c. But if that c is like less than 1, like 1/2, then when you compress by a number that's less than 1, all the x values are getting divided by something less than 1. That makes them bigger. Cool. Feel good? So, the point of these moves is that now, I'm going to jump right down here, is that you can combine these things together to sketch graphs of complicated functions that are built out of the elementary functions by using any of these elementary, well, I guess linear transformations. So let's see that in practice. Let's try to sketch the graph of, let's see, here I have f of x equal to root x. Let's try to sketch the graph of y equals 2 times the square root of x minus 2 plus 1. And here's how I'll advocate doing this. So the end graph should probably look something like the square root function. But I'll need to like do these moves to it. So I guess the first thing I see is the square root is multiplied by 2. Let's deal with that multiplication by 2. After that, well, I see a minus 2 next to the x. Let's deal with the minus 2 next to the x. And then I see a plus 1 at the end. Let's deal with that plus 1 last. That seems sensible? Let's see what happens. So I guess my starting point is y equals just the square root function. Oh, well, we already know what the square root function looks like. It's behind me. Its graph looks something like that. So let's deal with this first move then. So this first step, I'm going to graph y equals 2 square root x. So what does that do to the graph? Stretch it vertically? Nice. So maybe I'll put like a word there. You stretch vertically by 2. So I guess like you double y values. All right, nice. So right now, the only like labeled y value I have right there is 0, 0. Where does 0, 0 go when you double the y value?
Stays there.
Yeah, 2 times 0 is still 0. So in order to like trace what's happening, let me graph like one other point. I know that 1, 1 is on the graph of the square root function, so let's label that. Where does that point go when you double the y value?
1, 2.
1, 2. X value stays the same, y value gets doubled. And one very conscious choice I made when generating these pages is you'll notice those graphs have absolutely no hash marks on them already. I did that so that I couldn't have the scale incorrect, because there is no scale. A lot of times when you do this like graphing by transformation, you'll wind up with graphs that are qualitatively right, but I mean you can't trust any one of the values they go through because you weren't careful at that value. Anyway, next move. What's that going to do? So either you're making an offensive gesture at me or you're telling me something. Yeah. Move it to the right by 2. I'm not going to repeat the gesture though. So let's see, to the right by 2, 0, 0 will go to 2, 0. Good. And then it'll look like the square root function from there. And let's trace that point too. 1, 2 will become... Cool. You add 2 to all the x values. Last step. There's a plus 1 right there. What's that going to do? Up by 1. 2, 0 will become 2, 1. It'll look like a square root function. 3, 2 will become 3, 3. Groovy. That feel pretty okay? Nice. So, let's do one check first. Let's see if we believe that this graph is correct by just seeing if it has some correct properties that we'll check directly. By looking at that graph, what is a thing that you would predict about this function? What is its domain?
2 to infinity.
Cool. So the domain sure looks like it's 2 to infinity, and that's by looking at the graph. Oh, but we can also check domain algebraically, right? So I see, that's what the function is. 2 square root x minus 2 plus 1. If I just didn't give you any graph or anything, just ask you for the domain of that, what would you do? How do you figure out the domain of a function like this? Yeah.
Just make it equal to y and just kind of start trying on.
Oh yeah, so you could like, but we already did that. We looked at the graph already. I want to use the idea where we think about each piece and what could go wrong. So it's...
And by chugging along, and it like sort of solve it backwards, like so one side to y equals, and then say, okay, so subtract 1 to both sides, so it's like y minus 1 equals 2 times square root of x minus 2, and so on and so forth.
Okay, yeah. I think that would be a good way to like tell the range, because then at the end you would say, what y values could you get out of that? Say again. Yeah, so let's think about something interesting. So let's look at each piece. To figure out the domain, let's think about what could go wrong with each piece. So you start with x and you subtract 2. Is there any number you cannot subtract 2 from? No, you can always subtract 2. So like there's no domain restriction there. I see a square root function. What types of things can you see under a square root?
Greater than or equal to 0.
Greater than or equal to 0. So I see a square root. Let's put that in color to emphasize it. X minus 2 had better be bigger than or equal to 0. And instead of checking that right now, let's just look at the rest of the ingredients. Then you multiply by 2. Is there anything you cannot multiply by 2? So no restriction there. Is there anything you cannot add 1 to? No restriction there. That's the only restriction. That look like an inequality you can solve? What do you get? Cool. Those two things consistent? Looks like. So there's one way of like checking if your end result seems reasonable. See if it has a reasonable domain at least. Groovy. So, you'll notice that like I did these moves in this example in a very particular order. I dealt with the 2 in front of the square root first. Then I did this shift right by 2, then I did the up by 1. There's some subtlety in like the order that you should do these in. If you walk things out in a different order, you'll wind up graphing something different. And I don't think I want to emphasize like the subtlety of that right now. I'll leave that as a thing for you to think about. Instead, I'll endorse, if you want to graph a function, that's a function you know and then some transformations, first, deal with whatever is multiplied by the whole function. And let's just, so it's written on this page again. What does that do to the graph? Yeah.
It stretches or shrinks it.
It stretches or shrinks it in the vertical direction. And maybe flips too, because the a could be negative. So maybe I'll encode that with like the instruction of what to multiply by. So you multiply y values by whatever that plus or minus a is. So maybe that does a flip, maybe not. Maybe it stretches, maybe it compresses. Cool. So I endorse like doing these two both as second. You could do them one at a time, but I think I want to talk about them both at the same time. So the plus or minus c, what will that do to the graph? Yeah.
Shift it left or right?
Shift it left or right, and it'll be the opposite of what you expect. So I guess it'll be left by whatever that plus or minus c is, where left by a negative means to the right. What will the d do? Shift it up or down depending on if it's negative. So these two together, you'll shift left by whatever that plus or minus c is, and then you'll go up by plus or minus d. All right, happy so far? And I guess last thing, the b, I think that's too close a color to the blue. So that's a number multiplied by the x. What's that going to do to the graph? It will compress horizontally. So the x values will get divided by whatever that is. Ooh, is there something illegible? I can,
Oh, it's just that after the by plus or minus c, what's the next part?
well, it's not really legible, is it? Up. Where if you go up by a negative, it means you go down. All right, so this one will be, you will divide x values on the graph by whatever that plus or minus b is. So maybe you do a flip over the y-axis if it's negative. Maybe you do a compression or a stretch depending on the bigness of b. Cool. We feel good? So, I think here's what I want to do with most of today. Here are like 3 examples of things to go through. The first one is a lot like what we just did. We will start with the graph of the square root function, and we will end with the graph of negative the square root of 2x plus 1 and square root. Oh, and then I want a minus 2. And, well, let's see. I think this one we can talk through together. Though many of you are already starting and might be about finished on it. The next one, I think I'll have you work independently and compare with each other and ask me questions as we go. And then the last one, we'll see what we want to do. So, let's try to sketch this graph. I guess we want to start in the same place. The square root function is like the elementary function we can start with because this has square root. So, let's start with the graph of square root. And now, consulting like the instructions at the top of the page and moving the mouse. In this formula, what thing should I deal with first? I hear a 2x plus 1. Yeah, I'll do that first. That's right, the 2 was the thing next to the x. That's the one I want to deal with last. Yeah.
You want to deal with a negative in front of the function?
Yeah, the first thing to deal with is whatever you do to the whole function. You multiply the whole function here by a negative sign. I guess you don't multiply by a negative sign. You apply a negative sign or you multiply by -1. So I should deal with that first. So that'll give me negative square root x. There's the first thing to deal with. What's that do to the graph? So far I see like that hand motion, which seems right, but like, put it into watts. What is that?
Flips it over the x-axis.
Flip it over the x-axis. If you want to use like the watts at the top of the page, I guess you multiply all the y values by -1, but yeah, that's flipping over the x-axis. When doing this stuff, I avoid on my own saying flip over the x-axis or flip over the y-axis because I consistently say the opposite of what I mean. So, right, because like you're doing something with the x values, but you're doing it over the y-axis. I get that wrong all the time. Okay, cool. What's the next thing we should deal with? Yeah.
Add 1 to the square root of x.
Yeah, the add 1 on the inside. Let's deal with that next. So the next one is the negative will come along for the right, square root of x plus 1. Nice. What's that going to do to the graph?
Shift it left by 1.
Go left by 1. Cool. Feeling good? Cool. What next?
And or it would be, you'd make it negative square root of x plus 1, and then outside the square root it would be -2.
Deal with that one. So let's deal with that third. So that will put me at negative square root of x plus 1 and square root minus 2. What's that do to the graph?
Move it down by 2.
Down by 2? Nice. So I guess we should be tracking this like end point. Right now this is at -1, 0. I want to go down by 2, -1, comma, -2. Alrighty. Plugging along. What next?
Compress it horizontally by 2.
Compress it horizontally by 2. So let's see, that means all the x values will get divided by 2. So let's do that. There's the only point I see tracked right now, -1, comma, -2. Where will that point go when I do this?
-1. That's why it's
Divide all of the x coordinates by 2.
-1/2.
-1/2 is the x value. What's the y value? Still -2. The y values don't change. I was phrasing it like it was a deep question in hopes of like tricking someone. But I guess you didn't get tricked. So there's the coordinate -1/2, comma, -2, and then otherwise the graph looks like it looks like. That feel pretty okay? Yeah.
What does the -2 do?
Yeah, so this -2, what it will do is it will result in all x coordinates on the graph get divided by 2. So, right, the way to remember is it's inside the parentheses, so it's going to do the opposite of what's intuitive. It looks like the x in the function is getting multiplied by 2. So you would want like the x coordinates to get multiplied by 2. That's intuitive. But the reality is you do the opposite. What's the opposite of multiplying by 2? It's dividing by 2. And that's not like a proof, that's just a reasonable heuristic to keep in mind. Nice. People feel okay about this? Given the fact that I've just written all over this next graph right there, I guess I need to put that there. So, here's one. Sketch the graph of negative absolute value, 2x minus 3 and absolute value. plus 1. And I'll see how people are feeling. This is indicated as a you do exercise. People feel like they can do? All right. Yeah.
Do the absolute value signs, do those act like parentheses where everything is reversed, or no?
Yeah, so can think of this as being like absolute x. A lot of times, even when you enter this into a machine, you would enter that in as absolute value of x. So you should think of the absolute value versus being like a function, and the stuff inside those absolute value versus like the stuff in the parentheses. Yeah.
You have the extra note sheets.
In a sense. Happily, we are just finishing a notepad right now, so I can give you sections of the notepad. It's all filled in, which, upsides, downsides. So I think my office hour is like right after this class today, I think? That's right? If you want to come up by my office, I'll be able to print out some copies.
Okay.
Yeah.
Wait, did you say after class?
Yeah, just follow me upstairs. Oh, I should circulate here.
So the absolute values don't act as parentheses?
They do. You should think of all the stuff inside of the absolute values as being like in the parentheses function.
Okay.
Yeah.
So they reverse, so it's the opposite of what we would think.
All the stuff inside the absolute value.
Okay.
Yeah. Let's take a look. Yeah. That's the thing you wanted, right? That's the element of the one that has to do. Yeah, that's what we use that. Yes, x value, all the x values are values.
Okay.
So what's that x value right now?
That is 4, I think.
I think right now it's 3-1, right, because you went away.
Oh, yeah, this one right here?
Yeah.
Yeah.
So what happens when you divide the x value because you divide 2?
Oh, so it'd be like 1/2.
Yeah,
Okay.
it gets closer to the vertical axis, not like,
Yeah.
it's a parallaxis of symmetry.
Okay, what is still like compressed like that?
Yep.
Okay, gotcha.
Yeah.
So, thank you.
Yeah. And as, yeah. Yeah, that looks nice so far.
I have a picture.
Oh, okay, you lost the negative sign up front, that's what happened. Yeah. I saw it wasn't there and thought, oh no, you're gonna do the thing you should do false last. Cool. Let's come together and see how people feel. I don't know, do people want more time? Alright, so, this looks like it has to do with absolute value. So I think the reasonable thing is let's start with just absolute value of x. And I'm not gonna trace through the step by step unless there's demand. But absolute value has that interesting point at 0, 0. So I think I want you to describe the end result by telling me where that point ends up and whether it's an upward opening wedge or a downward opening wedge. So let's see, after you did this, there's this turning point. Where is the turning point in the end result? Just the quadrant you wind up in if you want careful, and the exact coordinates if you want. Yeah.
Like at the very end, where does it end up?
Yep. Yeah, I want the very end result.
1.5 and 1.
I hear a 1.5 comma 1. Do I hear a second? Nice. So I guess that's like there-ish. And then there's like a wedge shape. Does it open upward or downward? Upward is what I mean by this, and downward by that. Upward or downward? Downward. So, look something like that. And like somehow, I'm afraid now, because there are like two things it could look like, and they'll be visually different. It could be something like that, or something like that, and those will be like different looking. Which one of those should it be? Is it like wide, or is it squeezed skinny? Option A or option B? I hear a B. How'd you check?
So that checked was, no, it got compressed by the two points.
I like that. So it should be fairly skinny. People feel pretty good?
That would be A because it's the opposite, so it would be.
Ooh, so let's see. The step that got opposited came from like the 2 next to the X. So you think that's going to stretch it wider, but it's inside, so it does make it skinnier. And you know what? Let's go ahead and do this to check. Let's locate the y-intercept, because those two options were like differentiated by whether the y-intercept is positive or negative. How do you find the y-intercept? So you set x equal to 0, and then you just see what the y value is. So I guess that'll give me y equals, there's the function, negative absolute 2 times 0 minus 3 plus 1. You stare at that for a little bit, and where is the y-intercept? Yeah, we're eventually getting a y value of negative 2. Okay. So, yeah, down there at 0, negative 2. Cool. That feel pretty all right?
Nice. Wouldn't the it's it looks like I figured wouldn't the vertex change since it's for
Oh, yeah, I should be drawing on this. Yeah, so the vortex I think winds up at 1.51. And we found a y-intercept of 0, negative 2. And now maybe I'll see. Is there a call to talk through it? Cool. You're happy that I'm happy. So there's like, let's see, how am I doing for time? I've got like 6 minutes left. So I think we've got time for 1 of 2 plans of attack. Gazoon type. We can go through one more example, but starting with y equals x squared if we want. Or, on the next page, I propose combining these ideas with the ideas you already know from piecewise functions. So, let's just see what people think. People think they would benefit from one more example of this? Cool. Let's talk through it, and let's actually talk through it together this time. So, there's the function I want to graph. It's different from the one in the notes. I had a change of heart after printing that this is the one I want to do. So if there's the thing you want to graph, what function should I start with? That seems sensible, because that is built out of the squaring function, and then you do some stuff to it. Ah, well, I know what the graph of y equals x squared looks like. Cool. And now we have to play this game where we decide what order to deal with like each of the little ingredients there and what each one's going to do. So, you look at that, what's the first thing that you deal with? Nice. So all of x squared is getting multiplied by negative 1/2. All right, what's that going to do to the graph? Say louder.
It's gonna widen it and flip it over that axis.
Yeah, it'll flip it over the x-axis, and it will widen it, but really it's like compressing it vertically, which is, this is a symmetric enough thing that those are the same. So, still goes through 0, 0. It opens downward, but maybe it's a little bit flatter than it used to be. All right, what's the next thing I should deal with? There's like 3 different good options, yeah.
Let's do x, you change the x to x plus 2 squared.
Ooh, so we could do something like that. Minus x plus 2 squared. That's not the same as x plus 2 squared. Oh, no, I see what you mean. Okay, you're going to deal with the plus 2. Yeah, perfect. I got myself confused. Let's deal with the plus 2. How many people would rather deal with the plus 1 in this step? How many people would rather deal with the plus 2 and the plus 1 in this step? Perfectly sensible. You could do them both at the same time. I'll do just the plus 2 now. I have the space. So I still have the negative 1/2. It's still x squared, but now I've stuck a plus 2 in the graph. What's that do with the graph? Left by 2. Very good. All right, what next?
You're set.
Up 1. Oh, Chris, come on. This corresponds to that graph. And you all were just going to let me do it. Now I go up 1. Very good. And what next? Well, there's only one thing left, right? I see a negative next to that x. So what happens?
Flip it over the y-axis.
Flip it over the y-axis. The x values become negative what they used to be. So, what's going to happen to that vortex point? Yeah, the x value would become negative what it used to be, so negative 2 becomes 2. Y value stays the same. Nice. All right. Cool. And I see I'm shy on time. So maybe I'll say what things would be appropriate to do now that I won't be doing. Would it be reasonable to want to find the y-intercept? We've drawn it like it's negative, but maybe I don't know that the y-intercept is negative. But you can find the y-intercept by plugging in x equals 0. If it's not negative, then just fix the end graph. Do you think it'd be a good idea to find the x-intercepts too? That look reasonable to do? Cool. Nice. So, between now and when next we meet, it would be a good idea to go over that review document. That can be found on the course webpage. I have an office hour in 10 minutes, which is why my alarm is going off. Oh yeah, you can do, both of those steps can happen at the same time. You can go left 2 and 1.
And then I have the width of this is 2x and y, 1.
Yeah, because that'll tell you if it's like going out like this.
Okay.
You can also find the x-intercept too.
Thank you, have a good day.
You too. Ooh, that looks expensive.
Yeah, so I was sitting in the corner over there.
Added to the collection.
No, these are all actually mine. I don't need to steal.
So for the liaison Friday, is that we're gonna be doing that or
There would be the quiz would be the thing.
Okay, so, is it possible for me to then take it in the testing set?